What if the rest of Canada, North America, and the world could benefit from the wind and water that surrounds Newfoundland and Labrador every day? What if isolated communities could be powered by the renewable energy that surrounds them? Newfoundland and Labrador and Nalcor Energy are using technology to solve the energy challenges of today and tomorrow, providing opportunities for both economic prosperity and environmental sustainability. Newfoundland and Labrador has an immense and diverse energy warehouse. Wind and water contribute to our vast wealth of clean energy, positioning the province as a strategic, long-term supplier to meet the growing demands at home and potentially around the world. From megascale hydroelectric generation to microscale wind, hydrogen, diesel, the province and Nalcor Energy are bringing innovative energy to Canada, North America, and beyond.
We're pretty well at the base of Gull Island Dam on the Churchill River. The reservoir for the generating station would be behind us here, back up in the river valley.
The Lower Churchill is the most attractive, undeveloped hydroelectric project in North America. The installations at Gull Island and Muskrat Falls will have a combined capacity of over 3,000 megawatts and can provide 16.7 terawatt hours per year.
These two projects alone will produce about double the island's requirements right now and Labrador. So obviously there's an opportunity for export.
The Labrador Island Transmission Link would connect the island of Newfoundland with the North American electricity grid, allowing for two-way transmission and for further development of the province's energy sector. This link would also allow the province to displace existing fossil fuel generation at the Holyrood Generating Station, providing a solution to the air quality issues associated with that facility's emissions. This proposed 1,200-kilometer high-voltage direct current line will be constructed from Gull Island in Labrador across the Strait of Belle Isle to Soldiers Pond on the island's Avalon Peninsula, delivering up to 800 megawatts of power to the island.
Strait of Belle Isle, is pretty unique with regards to icebergs, pack ice. The rock that you're facing there is different.
Engineering analysis related to the subsea cable crossing focuses on two main options.
One approach is to place the cables on the ocean floor and then use a variety of techniques to protect the cables. Another alternative that we're considering is to build a conduit underneath the seabed, so effectively a small diameter tunnel, and then we place the cables inside the tunnel.
Installing the cables along the seabed would likely require two corridors traveling independent routes across the strait. A number of techniques can provide the required level of cable protection. Options include using natural seabed features, water jetting trenches, rock trenching, plowing and backfilling trenches, and creating rock berms, or laying concrete mattresses. On the Labrador side, tunneling and drilling will also likely be required from the shore. On the island side, the coastal area is relatively shallow. The intent is to trench the cable from the onshore stations. Engineering analysis on a possible full tunnel below the seafloor is progressing. Once complete, it will round out knowledge of the strait's ocean floor and the options for linking the two sides. The eventual approach will be based on an overall technical analysis combined with the associated economic viability while remaining sensitive to potential environmental impacts.
Once you're on the island, advancing or extending that cable over to the maritime provinces is well within the state of the art of today's technology. And I can cite a dozen HVDC systems around the world that are longer, that operate at higher voltage, that move more power than that extension into the maritime provinces.
Nalcor Energy is continuing to assess various markets such as Ontario, Quebec, the Maritimes, New England, and New York. All are still under consideration and could be accessed via Quebec's transmission grid or via a submarine route from Newfoundland into the maritime provinces. The Lower Churchill project could displace 10 megatons of greenhouse gas emissions annually from thermal generation in Atlantic Canada. The total output from the project's 16 terawatt hours annually is enough energy to displace more than 16 megatons per year of greenhouse gases from coal-fired generation. That's the equivalent of taking 3.2 million cars off the road. While projects on this larger scale can provide power to any community connected to the grid in North America, there are many communities in Newfoundland and Labrador whose geographic isolation requires a unique solution to meet their energy needs.
We operate 21 isolated systems such as this one here at Ramia across the province. There are 6 on the island of Newfoundland or on small islands off the island of Newfoundland. There are 15 in Labrador, and they all use diesel solely as their source of electricity generation today.
Although diesel generation is a reliable and effective way to produce electricity in isolated communities, it is directly tied to the volatile price of crude oil, and it produces greenhouse gases and other emissions. Integrating renewable energy into these isolated systems is an important investment in the sustainability of these communities, and the province is developing its very own innovative approach. There is no other energy solution for an isolated system quite like the Ramia Wind Hydrogen Diesel project. The project includes the installation of 3 100-kilowatt wind turbines. These will be used with the existing 6 65-kilowatt Windmatic turbines, an electrolyzer to produce hydrogen, hydrogen storage tanks and generators, plus a control system to integrate these components.
When wind is available and the wind is blowing and there is community load to match that, the wind will go directly to serve the load. When there's more wind than's needed for the community load, then we will be creating hydrogen. So the hydrogen is then pressurized and put in a cylinder and stored on site.
After a long period of low wind generation, the stored hydrogen could be used to fuel a hydrogen generator. Once all the stored hydrogen is consumed, the diesel engines would begin generating as they have traditionally. The goal of the project is to minimize diesel generation and, through research over the next 5 years, learn how to right-size the components and design a system to eventually eliminate diesel generation completely. The real innovation in Ramia is the monitoring and control mechanisms that integrate wind, hydrogen, and existing diesel. The system will monitor the inputs and outputs of these generation sources, the varying loads, environmental conditions, and the interconnectivity, integration, and efficiencies between them. And the technology is not limited to wind power. The wind hydrogen diesel system has the potential to integrate any renewable energy source: wind, solar, or tidal. Nalcor has extensive experience with the controls for diesel systems, but this will be the first opportunity to develop an integration system for multiple sources.
After the 5-year demonstration period, and this project proves itself a success, we can export that technology to the remaining 21 isolated systems to be able to bring renewable futures to those communities.
This project also holds great promise for isolated communities far beyond Newfoundland and Labrador. There are more than 100 diesel-powered communities in Canada alone, and a great many more around the world. This research and development project has the potential to eventually replace diesel with zero-emission power, and therefore has international commercial prospects. From the mega project scale of the Lower Churchill to the community scale of the Ramia Wind Hydrogen Diesel solution, Newfoundland and Labrador is embracing energy technology to harness renewable energy resources. We have the resources, we have the ingenuity, we have the skills and the experience. We have the technology to make it happen. We have the determination to move forward boldly and proudly. And it is happening in Newfoundland and Labrador.